Unit 6, Section 4. Here we're going to do some examples with the triangle proportionality theorem as well as the properties of parallel lines that we just learned. So for this first one, it wants us to show that the triangle proportionality theorem is true. So the triangle proportionality theorem said that if we took this piece over this piece, that the ratio of this over this, those two would be equal. So we cut it into little pieces, and we said because those lines are parallel, and we have this triangle, we can break it up into pieces and set it up as a proportion. So that's to say that I would do 4 over 2 equals 6 over 3. And so I'm doing segment to segment. That's what I'm comparing. And is that true? Well, 4 over 2 can be simplified just to 2. And 6 over 3 can also be simplified just to 2. So yes, it does work. Now there's one other way you could do this. You could also think about these as similar triangles. And so you can compare a small triangle to a big triangle. So I could compare this small triangle right here, up here on the top. I could compare that triangle to, let's see, this big triangle, the whole thing here. I'm not going to color all that in, but I'm talking about this big triangle right here. So I could compare and set up a proportion with those, and so if I was quickly to do that, I could say that the side length, I could just pick 2 side lengths. So if I picked this one here on the left, I could say 4 over the, so that's the little one, and then over the big one, 4 plus 2 is 6. That should be equal to this side, 6 over the whole thing, which is 6 plus 3, which is 9. And why not just do the last side? I could say that 8, it should be equal to 8 over 12, so the little one over the big one. And if I simplify all those down, I get, let's see, 2 over 3, cut that one in half, divide both those by 3, and I get 2 over 3, divide both those by 4, and I get 2 over 3. So that also works. So this is when I did little triangle over big triangle instead of segment to segment. It's just a different way to do it. It's kind of whichever one you're more comfortable with, or whichever side lengths you're given. It'll probably aid itself a little better to one or the other. So one of them is segment to segment and comparing those, and one of them is thinking about them as different triangles. So this next one, it asks us to find x, and we can definitely do either. We could think about that as the little triangle on top and a whole big triangle, or we can just think about breaking it up into segments. I kind of like breaking it up into segments, so I think I'm going to do that. So I would say this segment 12 over the other segment should be equal to the corresponding ones on the other side, the little one over the bigger one. I cross multiply, so 12 times 15 equals 10x. And if I solve 12 times, if I do 12 times 15 and divide that by 10, I'm going to get x equals 18. So that's to say that this piece is 18, which I believe. The next example, find x. Now this one, see, this is what I was talking about. I could do segment to segment, or I could think about it as little triangle over big triangle. And since I don't necessarily know anything about those parallel pieces, I think I'm going to do little triangle over big triangle. So I'm going to do little triangle, and I know I have that top piece is 6, and that long parallel line piece is the x, and that should equal the same pieces for the big triangle. So when I did 6 here, I'm going to do the whole big thing, so I'm going to do 6 plus 4, which is 10, over this piece, which corresponds to that x, so that'd be 20. So I'm thinking about a little triangle and big triangle to set up those. And if I was to redraw it over here, it's like I'm saying I have this, and that's 6 and x. and then I have the bigger one that's 10 and 20. And so I picked those pieces and I said that the proportion should be equal. If I cross multiply, I have 6 times 20 equals 10x. And then if I solve for x, I get x equals 12. Another example. Here to find x and y. So I know that these are all parallel lines, and with this line on the left here, I see that it breaks it up into congruent pieces, so I know that this other line, it has to break it up into congruent pieces. Not necessarily the same lengths, but all on that line, they're all equal. So it's essentially just setting these equations equal to each other to solve for x and y. So since I know that those two pieces are the same length, and this 3x minus 4, it's saying that this piece, that's how long it is, and then that's how long this piece is. And since I know they're the same, I solve. So I add 4 to both sides, add 2x, divide by 5, x equals 2. And then I do the same thing over here. Set them equal, because I know that they're the same length. So once again, I'm looking at this piece, and I know it's the same length as this piece. So I can set those equal to each other. Now I have a little trick. I sometimes don't like to mess around with fractions. So I'm just going to take this whole thing times 3. Every single piece. And I do that so I can get rid of that 3 on the bottom there. So I'm going to be left with 5y, because I have 3 over 3, plus 3 equals 9y, and that got rid of my fraction. You don't have to do that, but it's just a little clearer way of doing it. And then you subtract 5y, so 3 equals, 9 minus 5, which is 4y. Divide both sides by 4, you get 3 over 4, which I get a fraction again, but it's a little easier to get to. Next example that we're going to do in this video is number 5. And so we have these lines that are parallel. It tells us it's given, so k is parallel to m, which is parallel to n. And I want to find x. So I see that they're not the same distance apart. 10 does not equal 15, so I think I'm going to do some comparing of segments. So these are proportional, not congruent. Like the one we just did. Those were congruent. So I'm going to set up my proportion to do, I'm going to do 10 over 15 equals 15 over x. So I did this piece over this piece should be equal to this piece over that piece. Cross multiply. 10x equals 225. Divide both sides by 10. I get 22.5. So those are some examples using the different properties of proportionality and parallel lines. Look over those again to make sure you believe them, and that if you saw one of those problems on a homework or quiz or test, that you would know where to start and how you could set up that proportion. Stay tuned for the next video where we're going to explore a couple more theorems with right triangles.